everybody, it's Mr. Bosko. So last week we did an assignment using a pinwheel, and you should have taken it outside and had the wind blow on it and try to think what makes that thing turn. What is wind? Right? I got a picture over here of a tree blowing over with this stuff hitting it, and what causes wind? Right? You should be thinking about that. And then we asked you a few questions that you should have answered. And like I mentioned in my Google Classroom, I want you to answer these things based on, I don't want you to answer them. I want you to respond to them. Meaning, don't give me an answer. Don't go out and look up Wikipedia and just write down what Wikipedia says. Try to think. What do you think wind is? The more you struggle with what something is, when you finally realize and find out what that concept means, you learn it better. That's what science is all about. Scientists have these questions, they go out, they study it, and then they get the answer, and it's like an aha moment. That's what you need to be doing. Get those aha moments. You learn way more. Okay? All right, enough about that. But try it, okay? Don't go look up the answer. That doesn't do you any good. Try to think. Okay, so we're going to talk about what is wind. Wind. I mean, we feel it a lot, especially in the spring, right? So it's blows really, really hard sometimes. So we got to figure out, what is this stuff? So we're going to start off first. Wind, air. All right? We think of air. Air is just, well, first off, let's go to water. What is water? If I have a coffee, or not a coffee cup, let's say a water cup, and I've put water in there, what am I putting in there? I'm putting a pile of water molecules, right? We've talked about that. We've talked about it a lot. So if I put a drop of water on the table, it's just a pile of water molecules sitting there, kind of sticking together a little bit, right? 64 quintillion molecules of water make up a drop. All right. So just a pile of molecules in there, water molecules. Well, air is no different. Air is a pile of air molecules. Is there such thing as an air molecule? Well, air is made up of many different kinds of molecules. So in air, I'm going to write down air here. Let's start writing so I keep your attention. In air, you have nitrogen gas, or nitrogen, which you guys have seen the atom of nitrogen, right? It's capital N on the periodic table. And if I put a 2 here, that means 2 atoms of nitrogen stick together. That makes nitrogen gas. All right? In our atmosphere, we have mostly nitrogen gas, nitrogen molecules. And it's 78%. So it's almost 80% nitrogen in the air that we're breathing right now. The nitrogen is going into our lungs. And we have this important ingredient of our air molecules is oxygen. And that's, I keep forgetting. I'm pretty sure 21% oxygen in our atmosphere, in our air. Okay, less than 1% is an atom called argon, and that is less than 1%. Okay, if you add this up, 78 plus 21 is 99%, less than 1%, so it's like 99.9 something percent is mostly nitrogen, oxygen, and argon. But there's also other molecules in our air, like CO2, a very important greenhouse gas that we should be learning about. And there's also, believe it or not, H2O. H2O in a gas form, like when you boil water on the stove, you see that oxygen gas. We're breathing in, water in a gas form, H2O. We're breathing in water molecules right now too. Okay, so this is just interesting, but I'm going to draw, here's those are lips, I guess. Here's somebody, all right? Let's not say it's any of us because he looks silly. And down here, let's say here's where you breathe in. I shouldn't even be going here. I'm sidetracking. Goes down to your lungs, all right? This is just a little human anatomy. Not very good stuff. But so out here in our air, we have all these molecules, right? Mostly nitrogen, some oxygen, and a little bit of argon, all right? When you breathe in, your lungs are getting filled with mostly nitrogen, some oxygen, and just a little bit of argon and all the other stuff, right? And your lungs in here, though, they're going, I need that oxygen. So they start grabbing all the molecules of oxygen, pulling it into your body, all right? So now there's no more oxygen, but your body will take carbon dioxide that it doesn't need and put it back out into your lungs. So now you got CO2 in there. When you breathe out, you're breathing out CO2 and nitrogen, some argon, all that other stuff. You're getting rid of all that other stuff. Why did I go down that path? I don't know, but it's dealing with air, right? Okay, so we have air in our air that was all surrounding us, mostly nitrogen, oxygen, argon, molecules. Like when you move your hand really fast, you feel your hand hitting all those molecules. All right. Woo! I went down the way long path there, didn't I? Okay, so let's move this down. Let's move it like right here. And so we talked about air. We talked about, one thing I want to talk about is let's draw a picture. I'm going to draw a picture of Earth because we got to talk about this. Air that surrounds a planet is called, starts with an A. Let's see, I'll get my orange pen back. If it's air this is our air that surrounds a planet. It's called what? It's not air. Well, it is air, but it's called atmosphere. Atmosphere. Okay? An atmosphere. That's all an atmosphere is. Whoa. An atmosphere is nothing more than air that's surrounding a planet. All right? Out here in space, there's no air. There's no molecules. It's devoid of molecules. There's no molecules. But surrounding planets, some planets, there's air. And that's called atmosphere. Around Earth, our planet, it's, why can't I write? And that's where our 78% nitrogen, 21% oxygen, that's what's surrounding Earth, okay? I'm going to try to make this quicker here. Okay, so we got all this air surrounding Earth, all these molecules surrounding Earth, which is air. And they're affected by gravity. Gravity it holds us to the Earth, right? It also, believe it or not, is pulling these little teeny molecules and atoms down toward Earth, just like everything else. Gravity pulls toward the center of a body, Earth. And they're getting pulled down. So as you, further way up here, there's still molecules, but there's not as many. There's not as many molecules up high in our atmosphere because gravity's pulling them down. If you get closer to Earth, you have a lot more. It's more dense. The air is more dense closer to Earth because gravity's pulling it all down. All right? Little teeny things you can't even see, but gravity's affecting those, okay? So that's important to know. More dense down low than it is up high. When you go, if you ever go mountain climbing, mountains go way up like this. Well, not that high, not even close to that, but I'm exaggerating. But the higher you go on a mountain, the less oxygen and air there is, less molecules there are. So a lot of time, if you see people climbing Mount Everest, the tallest mountain on Earth, you'll see them wearing masks and with bottles that has air in it because there's not a lot of air up there. They have to breathe using this mask. So again, I got sidetracked. I don't know why I do that. It's just so cool. Science, man, it's cool. Okay, so let's move down now. We talked about air. We've talked about atmosphere. We've talked about the density of air being more molecules closer to Earth than high above Earth. All right, so now let me choose green, and I'm going to draw just landform. So let's say there's some flat land, and here's a mountain. Okay, all right, and this doesn't have to be desert, but let's just say it's not a mountain. Okay, and we have the sun. The sun's up here, and the sun's shining its light rays down toward Earth. And when it shines its light rays down toward Earth, it's warming the soils, right? You got that? Light rays come down, the soils absorb the light, light energy and converting it to heat energy, right? All right, enough about that. Okay, so I'm going to use, I'm not going to use white. Let's go back to our orange for our molecules. We know out here to make up our atmosphere, the air that surrounds us. I'm having a tough time. We have molecules all over the place out here, right? They're all over the place out here. That's what we're nitrogen, oxygen, argon, and other stuff, right? Other molecules. Okay, so hot versus cold. What is the difference with molecules when we heat them up? What happens differently? We've done this in class. When you heat up molecules, they do something different than when they're cold. They move faster. Exactly. So they move faster. So the hotter a molecule is, the faster it's going to be moving and vibrating. All right? The colder they are, the less they move. And the less they move, the closer together they want to be. They condense. That's what makes clouds, right? Condensation is all of these molecules that come closer together. Typically water molecules. The water cycle, we talk about water. So water molecules condense, come closer together. But all of these other air molecules are doing the same thing. They're coming closer together. Okay? They just don't have the same properties as water, so you don't see them. Okay? Like in a cloud. So as these ones get cold, over here is cold air. Higher you go, the colder the air. Mountains are higher, so there's cold air, and these ones are going to condense. Condense. Condense is just another word for coming closer together, right? So they condense, meaning they go toward each other. They form this big, tight, you can think of it as a tight ball up in sky, okay? Up in the sky, don't giggle. Okay, so now we have this tight grouping of air molecules, and as they get tighter together, they become heavy. They just think if you take a bunch of sand, just a sand particle by itself isn't heavy, but if you take a handful of sand and put them all close together, it becomes heavy, right? Okay, so now what we have is air. That's the same thing. You got this big group of air. Well, we have gravity down here. Gravity, the force that's of downward force toward the center of a body. So we have this gravity pulling things down. It's going to take this big group of air and pull it down. It's getting pulled down. Cold air condenses. Cold air sinks. Gets pulled down toward Earth. All right? So if you hear hot air rises, cold air sinks, this is the reason. Cold air condenses and gets pulled down. So as this air, we're getting to wind. It's getting close. Get excited and stay with me. So this cold air comes down, right? And as it comes down, it gets pulled down. What's happening to all the molecules that are sitting here? Just think, if you take I don't know, I can't even come up with an example. You take something and drop it, it's going to push everything up below it away, right? So what's happening is all these molecules here are getting pushed out of the way. And I'm going to choose a different color because we're going to have arrows. So it's going to push these out of the way as these come down. These molecules, now this molecule is going to hit this molecule and push that out of the way. This molecule is going to get moved. This molecule is going to get moved. Over here we have hot ground. The ground's hot. The sun's coming down, striking these, making them vibrate more because they're warmer, so they're moving more. As these move, they move apart. They become less dense. They get pushed out of the way, and what's going to happen is these guys are going to go up. Hot air rises because it becomes less dense. Unless we've talked about it in class, that might not make sense, but items that are less dense float on top. So when you're fishing and you have a bobber on your line and you throw it out there, the bobber or a piece of wood is less dense than water, so it sits on top. This air is less dense. It's further apart. So it's going to move up and float basically on top of the air that's in our atmosphere. So all this air is moving out of the way, going up. This air is moving across this way to fill in this gap. nature wants stability. It wants like a relaxing area. It wants all the molecules to be spaced evenly apart. That's what nature wants. Nature doesn't always get its way. Not happy. Doesn't be happy about that. So all these molecules being close together, nature doesn't like that. It wants to take all these molecules, get them spread apart. So it's pushing them over here to this area where there's less molecules. If you listen to the news and you listen, or the radio, and you hear them talking about a low pressure area causing wind, low pressure. Uh-oh. Low pressure. You hear about low pressure, it's because all these molecules are spread apart. You'll hear about high pressure. High pressure. Okay, you'll hear about high pressure areas and low pressure areas. The air is going to go from a high pressure area to a low pressure area. It's going to scoot right across here, try to go there. Well, guess what? All these molecules moving, that's wind. That's wind. Let's get a picture of us. Let's make us some new color. I don't know, green. And so let's say we're standing here. You're feeling all these molecules hit you in the face, in your body, and it's pushing you over. The faster it's moving, the stronger the wind. Trees are bending over because of that wind. Oh. So you get what wind is? Wind is just the movement of molecules. I could have said that at the beginning, but that's no fun. I wouldn't have this cool drawing right now, right? So sun is warming up the ground. Sun's warming up the ground, causing these molecules to spread apart. Up here in the mountains, the cold air is pushing those molecules together, making them dense. Gravity pulls them down, shoots all of that air across the earth. There's wind, folks. Here, mic drop. You got it. Wind, all right? Take care. You guys take care of yourself. Be safe. Please, please, please be safe out there. I'm thinking about you every day. And next week, we're going to be talking about a sundial and how it works. I'll teach you all that too. Take care. Bye.